Let's now look at a word problem example. A basketball team scored 70 points in a game. The number of field goals, those are 2 point baskets, was two more than the number of free throws, 1 point baskets, and the number of free throws was one more than two times the number of 3 point baskets. What combination of scoring accounted for the team's 70 points? Okay, what combination of scoring? So this is asking us how many field goals did we make? How many three pointers were made? And how many free throws? There are three values that we need to find. And whenever you have unknowns, we should assign them a variable. Let's call the number of field goals x, and the number of three pointers y, and the number of free throws z. Because we have three unknown values, that means we are going to have to come up with three distinct equations to allow us to solve this system. Let's see if we can't come up with a couple equations based on the sentences that we have here. We know that there is a total of 70 points scored in the game. That would be the sum of all the points from my field goals, all the points from my three pointers, and all the points from my free throws. Well, that means field goals, because they are worth 2 points each, two times the number of field goals, or 2x would give me the total points from field goals. Three pointers being worth 3 points each, 3y would give me the total number of points from my 3 point baskets. And because free throws are worth 1 point, 1 times the number of free throws will give me the total number of points from free throws. Adding those all together needs to give me 70. 2x plus 3y plus z is equal to 70. That will give us our total number of points. Let's now look at the second sentence here. The number of field goals, right, and the number of field goals we represent as the variable x here, was can be translated into equals, x equals two more than the number of free throws. Well, the number of free throws is z, which means x is going to equal z plus 2, two more than the number of free throws. There we have a second equation. And finally, let's continue to read here. The number of free throws, that's z, was translates into equals, z equals one more than two times the number of three pointers. Well, three pointers is z. That's going to be 2 times z plus 1. Sorry, 2 times three pointers is y. 2 times y plus 1. Z is equal to 2y plus 1. So there we have three equations and three unknowns. All right. Z, the number of free throws, was one more than two times the number of three pointers. Three pointers is y, 2y plus 1 equals z. So we just generated a system of equations. Do we know how to solve systems of equations with three variables and three unknowns? Sure. We want to try to take this complicated system and turn it into a system that only has two variables or two unknowns and solve from there. Taking a look, we recognize that by substituting the third equation into the second equation, we eliminate the variable z. Plugging in the third equation into the second equation, replacing z with 2y plus 1, we get x is equal to 2y plus 1 plus 2, or x is equal to 2y plus 3. So now I have an equation that just has x's and y's in it. Well, how can I get another equation that only has x's and y's? We can do so by substituting the third equation into the first equation. We take this third equation, we substitute in 2y plus 1 for z. That gives me 2x plus 3y plus 2y plus 1 is equal to 70. Combining our like terms together here, we have 2x plus 5y, and subtracting 1 from both sides gives me 2x plus 5y is equal to 69. All right, so doing that substitution gave us now two equations that have the same two variables. And we can now solve this system using our two new equations. The easiest way to solve this system, probably substitution, right? We've already got our x value here isolated. We can substitute in that quantity for x into the second equation here. Okay, that gives us 2 times 2y plus 3 plus 5y is equal to 69. Carrying on with our algebra, we distribute the 2 through here. That gives me 4y plus 6 plus 5y is equal to 69. 4y plus 5y is 9y. If I subtract 6 from both sides of the equation, we get 9y is equal to 63. Dividing both sides by 9 leaves us with y is equal to 7. So we have solved for one of our variables y. Notice that in this equation right here, if we know y, we can get x. We can back substitute into this equation here to solve for x. We can also back substitute into this equation here to solve for z. Notice we have y is equal to 7, z equals 2 times 7 plus 1, z is equal to 15, and that leaves us with another option for solving for x here. All right, we can plug in 15 for z. X is going to be equal to 17. Notice I could have used this equation up here to solve for x as well. That would give me x is equal to 2 times 7 plus 3. 2 times 7, 14, plus 3, 17. X is equal to 17, giving us the same result. All right, so again, you can do your back substitution in a number of different ways. If we're doing our algebra correctly, we should arrive at the same final answer. So now that we have our variables x, y, and z, we know x represents the number of field goals. We have 17 field goals, 7 three-point baskets, and 15 free throws in this game, accounting for a total of 70 points.